Hi everyone. So my name is Rona, and I'm a venture capitalist. I'm a bit sick, so I came sick today because I promised. So excuse me. And really, I see my business as not about so much about investing as about telling stories or storytelling. And really, it's about making up stories about the future, investing sometimes tens of millions of dollars in them, and really hoping that they will come true. And today I want to tell you a story, such a story. It's a story that is really my favorite one, and it's called Cloud Native. And actually, our story starts 4.5 billion years ago, when the Earth was formed by cosmic dust and huge stones that collided into each other. Quickly afterwards, there are signs of first organisms on Earth, okay? And it's quite amazing if you think about it, the conditions on Earth were unbearable. But still somehow, which is called the secret of life, those organisms emerged. But what is really fascinating is that 3.5 billion years ago, they were already doing photosynthesis, okay? Which is rather cool. And those stones that you see here, those weird stones, are not really stones. They are the byproduct of huge communities, sometimes billions of bacteria that were working together in order to create shelter from the environment. So those weird 3D structures are actually their home or their houses. Now, this is the first time, or one of the first time, in the evolution that we have signs of what we call complex adaptive systems. And I want to spend a minute telling you a little bit about complex adaptive systems and what complex adaptive systems are. And I'll start by telling you what complex adaptive systems are not. So your car, not your autonomous car, but your regular car, is not a complex adaptive system. It's actually what we call a complicated and deterministic system. By complicated, we mean that we have a lot of parts and it's really complicated. I have no clue how my car is working, by the way. But you need all the parts, okay? And you need all of them at the exact location. So, for example, you have 4 wheels. You can say that this is redundancy, right? Well, it's not in that system. Don't try to take one of them out and don't try to move them, okay? It's deterministic in the sense that if I press the brakes, I know that there's going to be a chain of reaction that will come with the exact parts at the exact locations, okay? But something strange is happening, and it's a linear system, excuse me. So if I press the brakes hard, if I push it really hard, the whole system, okay, will respond in a way that matches this. The car will stop faster, okay? So there is a connection between the strengths of the input and how the system behaves. But when I get into the car and I start driving, I'm becoming an agent in a system which is called complex adaptive system traffic. Okay? So the minute I start driving my car, me and the other drivers, okay, actually agree together that in order to get home faster, okay, and in the safest way possible, we should probably all follow some really simple rules. For example, let's not hit each other. Let's stay on the lane. Let's keep some distance from each other. Let's not run over kids that are running in the streets. Okay, some really simple rules. But surprisingly enough, although when we look at each agent, their behavior is quite predictable, okay, when all of those agents start interacting with each other and interacting with the environment, the behavior that emerged is something that looks really chaotic and unpredictable. And this is why applications like Waze are so successful. Because although, okay, you drove from work to home thousands of times, every time you go on the road, it could be something else, okay? You never know. Now, those systems are non-linear, and this is really important. So a really small disturbance can create huge, okay, impact on the system. And I think we all experience that when we have all kind of demonstration or someone is blocking a road and suddenly the ILON is blocked, totally blocked for hours, right? So those systems are non-linear. It is important to remember that they are not random, okay? They are behaving. There is a certain rule. This is just an emergent behavior that looks very, very strange. Now, those first complex adaptive systems of huge communities of bacteria were actually so successful that during billion years, okay, they transformed the Earth's atmosphere totally. They emitted so much oxygen, okay, and took over the Earth that right now we are living in a world that they created. They were living in an atmosphere which is full of oxygen. And in the process, they killed any other organism that couldn't adapt. Still, it took them another 2 billion years, or almost 2 billion years, to realize that they don't need to rebuild this house every time. They can actually have a permanent house, which is skin, okay? And what you see here is what scientists believe to be the first organism or the first animal that ever lived on Earth. It's some kind of a jellyfish. It's basically a ball full of cells, full of agents, floating in the water. This is a huge step in evolution. But for us, from our very narrow perspective of complex adaptive systems, the real major breakthrough happened 150 million years afterwards, when another complex adaptive system emerged, and this is the brain. Okay? Now, the brain is a very strange complex adaptive system because it doesn't exist by itself. It is always connected to another complex adaptive system, which is our jellyfish, or a ball full of agents, right? Now, let's think why it is such a big major, or such a breakthrough. Think about this jellyfish floating in the water, okay? Basically, it's just a bag full of agents that are responding to each other, responding to the environments, and suddenly a prey goes by, so they can sense it and they can, do something about it. But this jellyfish cannot hunt. In order to hunt, you need a central command center, okay? You need something that will actually tell the cells what to do. And this is exactly what the brain added to this equation. So the brain did not change the jellyfish, okay? It just added another layer. It actually created a hybrid system, a system when we have a control center, but it also decentralized in many other aspects. Now, this was a major breakthrough. And in 10 million years, which is nothing, it's just seconds, okay? The Earth was filled with species. The oceans, we had thousands of new animals. All of them are hybrid complex adaptive systems. And scientists are still saying, well, we don't know, it's magic, we don't know how it happened. Well, I just told you, well, maybe. Most of those animals will not survive, okay? In the next 550 million years, Earth went through some horrible natural disasters that each time almost totally extincted all the living organism on Earth. But somehow, in a rather miraculous way, those hybrid complex adaptive systems managed to survive and to swim out of the sea, develop limbs, control the Earth, until 200,000 years ago, more or less, the single most sophisticated hybrid complex systems emerged, and this is, of course, the Homo sapiens. Now, this system was so successful, okay, that in nothing in terms of evolution, it managed to dominate the Earth, okay, like no other species before, and develop amazing technologies like computer and quantum and gene editing and nanotechnology and whatever. But what really differentiates these systems from other systems is that for the first time, a complex adaptive system was able to create other complex adaptive systems to support its existence, okay? We created societies, we created economies, we created traffic, we created the stock market, social networks. We actually created so many complex adaptive systems that there is a name for it. It's called human-made complex adaptive systems. And one of the most sophisticated complex adaptive systems that we created is deep neural networks, okay? So unfortunately, this is not the subject of our talk today, so you'll have to take my word for it. But when people are talking about the dark secret at the heart of AI, and I don't know how many of you heard about it, what they're actually talking is about this feature of complex adaptive systems okay, that their behavior is looking chaotic and unpredictable, and this is why we are training deep neural networks. We are basically doing trials and errors. We don't really fully understand how they work. But today we are here to talk about cloud native, so why am I talking about evolution and other stuff with you, right? And hopefully you'll see in a minute how everything is connected. But let's start by defining what is cloud native. Because, you know, people are saying cloud native, but they mean very, very different things. So let's just think about what we mean. And in a very simple way, we can talk about two layers. The first layer is the hardware. Those huge modern data centers with millions of computers that are connected to each other, and those data centers are connected to each other, right? They are all virtualized and elastic. Now, I include in it public data centers and private data centers, because if you think about it, the only difference between a public and a private data center is that in a public data center, we encourage strangers to use our infrastructure, and in private, we really try to prevent them from doing so, okay? So this is kind of the main difference between the two. Now, we already have thousands of data centers all over the world, and in any given moment, there are a few more hundreds that are being built. The world as a universe is investing trillions of dollars in building those huge data centers, but we also need to feed them. And you know what they eat? Well, electricity. They eat energy, of course. Already 10 to 20% of the world global electricity is aimed towards feeding these huge computer mesh. And if we won't find a green solution soon, in 10 years from now, it could be as high as 50% of the global electricity. And there are already tens of millions of people that are working 24/7 all over the world in building components for this computer mesh, installing them, maintaining them, building them homes, okay? So we are investing a lot of work, money, and energy in building this computer mesh. Now, on top of this computer mesh, there is a new form of software that is spreading, and it's called microservices. And usually I do explain what microservices are, but I thought that in this room, I can skip that, right? Okay, hopefully, yeah. There are already today hundreds of billions of services and functions that are being executed every year, okay? Very soon it's going to be trillions and then tens of trillions. And of course, amidst all that, we have proliferation of AI models, and no matter if you call it machine learning or deep neural networks, but just spreading all over. And the first question that I want to ask you, and I was asking myself, after we realized how much money and time and effort, energy we invest in building this computer mesh, is do we control it? Is it ours? Do we own it? And I asked some really smart people, and the answer I got was, sure, we can always unplug it. It's a good answer. If you can kill something, you probably own it, right? You probably control it. But the second question that immediately comes to mind is, okay, great, but what will be the cost of doing so? And this is actually not a theoretical question, because Lloyd's, which is a big, big insurance company, actually asked that exact same question a few months ago. They asked, how much will it cost to the US economy if we shut down only the public clouds, only in the US, and only for 3 days? And do you know what was the number that they got? Can you guess? $25 billion. Now, we all know that our dependency on the cloud is growing every day, right? So now I want to ask you, what will be the cost in 5 years from now if we shut down all the clouds, the public and private clouds, all over the world for 2 months? Okay, I don't know the number, but I have a feeling that it probably destroys everything that we call human civilization. So if you are with me on that and you agree with me that probably shutting down the cloud is not an option even today, the second question that we need to ask ourselves is, Okay, so do we control at least what is running in it? Do we control microservices, or can they evolve in some mysterious way or some, like uncontrolled way? Now, this is a weird question, especially to ask, software engineers, okay? They are kind of control freaks, right? But 2 years ago, in the big DevOps conference, Josh Evans, who back then was the chief architect at Netflix, and now at GitHub, actually stood on a stage and told everyone in the room that microservices are organic systems. And the reason he said that was because microservices are, again, another human-made complex adaptive systems. And now you see why I was bothering you with complex adaptive systems. And I want to take our body and just make kind of like a simple comparison. So in our body, we have hundreds of different types of cells and tens of trillions of instances of those cells. Each cell is independent and doing its own thing, but when we combine them together, we get tissues and organs and a huge variety of organisms. In the same way, in microservices, each service or function is independent and different, but when we combine them together, we get processes and systems, and you know what? Sometimes they even include a brain. Each complex adaptive system needs a communication system. So in traffic, we use our senses. Our body is using chemical messengers. In microservices, we're using APIs. And like any other complex adaptive system, those systems can grow and can change. Now, I want to take you back to our kind of image of bag full of agents, right? Full of cells. The ways those systems grow is by adding more agents. I don't know if you know that, but when we grow up from being kids to being grown-ups, it's not that our cells are becoming bigger. We are adding more and more cells, okay? This is how all those complex adaptive systems work. And the same thing is happening with microservices application. When we want to scale them, we basically replicate instances, okay? We add more and more instances. And when we want to change them, we either change the rules and they change. Now, at that point, you should stop me and tell me, Rona, this is cool, and you definitely have kind of like vivid imagination, but come on, microservices are being managed centrally right now, okay? And all the other examples were decentralized, and you're totally right. But if you're software engineers, and I think most of you are, you also know they're trying to manage thousands or tens of thousands of instances in real time when they have to react to a very dynamic and unreliable environment, okay? It's not practical. It doesn't scale. Just the time it's going to take you to take the status or to communicate with all of them, analyze and send it back, you won't be able to respond in real time. And this is why scientists now, okay, and it's a very vivid area of research in the universities, are researching something which is called bio-inspired models of self-adaptation, which is a very fancy name to actually saying, let's look at how our body is managing trillions, okay? Or plants or a mouse is managing trillions of instances in real time, and let's take some inspiration. And there are some really cool things that right now scientists are working on. For example, they're adding to microservices, the ability to sense their environment. So actually understand what is happening around them, what is happening with the host, and then make all kinds of decisions to change their behavior, okay? To reroute traffic, to replicate themselves in a smarter way, okay? And there are many other really, really cool examples. And in a very similar way to the way that other organisms or a complex adaptive system can get sick or mutations, we have that as well with our microservices, okay? So no matter what you do, no matter what anyone will promise you, you will always have a certain error rate, okay, in your services and in your functions due to bugs or misconfigurations. And there are tons of malwares. I just read that last year, security companies estimated there are 8 new 800 new malwares that are being released to the cloud every minute, okay? Now, most of them are going after your IoT devices, mobile devices, and laptops, but more and more are now targeting cloud services. And the most important feature, actually, of those systems is the fact that they really challenge our ability to comprehend them. Now, this is something that most developers will find very, very hard to accept, okay? We used to have someone who is the chief architect, and he or she knew everything about the system. And then Netflix were the first one who actually came out and said, this job description does not exist anymore. With this type of complexity, there is no one in the company who can comprehend, okay, the system, who can actually understand all the different aspects of a microservice application. And this is something that I really want you to remember, because we will talk about that more and more as we go on. And now I want to ask you again, can those systems evolve independently? Is it possible that a random chain of events that maybe starts with a malware, just a misconfiguration, will start a process somewhere that is doing something? Maybe we are not even monitoring it. Maybe we are, and we have this red light somewhere. We don't know if it's significant or not. The second question that I want to ask you is, why does it sound so scary to you? Okay? Because we are surrounded by complex adaptive systems that we don't control, okay? Like our societies and our economies, okay, and many more, and it's okay. And actually, the fact that we don't control them is what makes them so adaptable and what makes them grow and change with us. But this is really a philosophical question that I want to leave with you. But if you look at online, and probably also in the talks today, I haven't checked, but I'm quite sure, you will see that, you will hear that there is no problem controlling microservices. What you really need to do, I'm going to really summarize it to you, use the best tools out there, okay, and they're great tools. Use Kubernetes and use Istio if you haven't read about it, and just follow the best practices and everything will be okay, okay? But I want to disappoint you. When you reach 40, 50 microservices, I'm not talking about hundreds of microservices, everything is going to break, okay? And I'm going to give you two examples. One example is when you look online and you look about design and microservices, you see that people are really advising you, and those are really good advice. You should follow them to keep it simple and to avoid dependencies. Have you read that to avoid dependencies? It's really important. But what is happening in real time is that every service that you add another dimension to the complexity of your system. At the area of 30, 40 microservices, your system is going to be so complex that there is going to be no one in the company that will fully understand that. Asking people at that point to avoid dependencies is similar to asking a blind man walking in the room not to hit objects, okay? There is no way that you can do it. And actually here I have a really funny story. One of my friends is a senior DevOps at one of the most successful and most advanced SaaS companies in the world. And he told me that for SLA reason, they decided that they need to map all the processes that they have in their microservices application. Now they have 300 microservices. So they set all those smart guys together and they decided on an approach. They will take the biggest wall in the company and you see here the wall, it's not really their wall, but they'll take the wall and they'll paint all the architecture and then they'll split it to squares and each team will get a specific square and start to drill down, okay? Now this is really cool. When he talked to me, they were doing it for 3 months. They didn't get even near, they weren't even close to finish. I don't know how they thought about combining all those teams together, but the weird thing is that how many changes do you think the system went through in those 3 months, okay? And what will happen immediately after they'll be done with doing that? So what I'm actually telling you here is that you should try to keep it simple and to avoid dependencies. But trust me, it's going to be very complex and there are going to be tons of dependencies, okay? And another example is monitoring, okay? So if you want to look online and look at monitoring, you see that it's really not a problem, really. Tracing and monitoring is not a problem. The only thing you need to do is collect logs into a central place, and then you have amazing dashboards, okay, that will show you everything. Now, what is really happening in real time is that you start collecting logs, and then you need to ask yourself, how many logs I'm collecting? And I'm doing it from each region, from each zone, on each instance. If I'm doing serverless, do I need to collect logs every second or every minute? What will happen very soon is that your storage costs are going to be, or elastic costs are going to be amazingly high, okay? And what you're going to get at the end of the day is a dashboard full of graphs and, flashing lights, and you'll have no clue what it means. Now, this is a really interesting topic, and Adrian Cockcroft, who is head of strategy at Amazon and someone I personally worship, was talking about that as one of the major issues that AWS is actually dealing with. And he told the world in a conference that 20% of Amazon operating cost is going on actually trying to maintain this huge monitoring system. But there is another side effect which is terrible. You're going to start getting so many alerts that you're going to collapse. Now, Financial Times released a blog, and the lady that was managing DevOps actually described how they inserted a monitoring system and told the world that they started to receive 25,000 alerts per day from their system. And I told this to my friend from the SaaS company. So he laughed and said, come on, they're idiots. We actually reduced it so much, we are only getting 5,000 alerts per day. Well, good for you. But this is something which is real, okay? And this is part of the fact that, and we'll talk about that monitoring system that we cannot comprehend is a real issue, okay? And we need to think about it in a bit different way. Now, already 5 years ago, a really brave group of people from Netflix came out to the world and say to everyone, listen, our microservices application is chaotic and unpredictable, okay? And they came out with a set of tools, and they said the solution is to break your system in production, okay? Now, it sounds crazy, I know, and everyone responded to that, like, wow, they are totally lost it. But only 5 years afterwards, okay, people are starting to talk about chaos engineering. And if you haven't heard about chaos engineering, I really fully-heartedly recommend that you start learning about it. Because what basically those Netflix guys said, without calling it complex adaptive system, is that they described a complex adaptive system. They described a system, okay, that even when everything is working perfectly, okay, is starting to behave in a chaotic and unpredictable way. They described a system which is non-linear. They said, even a router somewhere, a browser of a user, okay, can have a huge impact. And this is why they insisted on doing it in production. And the reason they were asking companies to break their applications is connected to an amazing scientific discovery about complex adaptive system, which is called the edge of chaos. It turned out that those complex adaptive systems, when you take them to the edge, when they are about to break, they start to behave in actually a quite predictable and organized way, which is really weird. And then everything breaks, okay? So scientists are now exploring ways, maybe, how to use this state of about to break in order to bring them back into a state that we actually know. Now, you will not read, the Netflix guys are not talking about those crazy stuff, I'm talking about them with you, but you can read between the lines that they are aware and they know about those scientific discoveries, okay? So those guys are really like, for me, are kind of like people that we should really look up to, but how brave and how kind of open-minded they are. But why a VC from Tel Aviv is bothering you with all those complex, crazy, chaotic stuff, okay? Why do I care about it? And the reason is because, first of all, I have a problem. I'm obsessed with what is happening with cloud native. I think it's just one of the biggest philosophical changes that the world is going through, not just a technology change. But second, I think it presents a unique opportunity, okay, for people that are able to think outside of the box, that people that are creative, to build the next wave of really big companies. Because cloud native or microservices applications are not just monolithic application that grew a little bit, okay? No, it's a very, very, very different animal. And I told you before that we make up stories and then we invest in them, and actually, here is a proof, we invested in 9 companies in this space. And all of those companies are taking a very unique and different approach, whether it's security for complex adaptive systems, which is PureSec, which we have Avi here, and Ori is going to talk later on, or Aqua security, whether it's testing for this world, GitHub, GitOps, and many other. Really, some of those companies here are really, really cool. But there are still some areas that are unsolved, and those are areas that I really urge you guys to think about. I'll just take the water. Testing, for example. I've been talking to people for over a year now, to entrepreneurs, about testing in production, really urging people to come up with ideas about how do we do testing in production. And now that you are expert in complex adaptive systems, you can understand why, okay? You cannot isolate the system, parts of the system. You have to test it in its real environment, otherwise you're testing a different system. How do we do testing? Okay, in a system that we cannot isolate part of it, that we don't fully comprehend. Do we have to do testing? Like, look at our body. Do we have testing in our body? It still works, right? I don't have answers here, but I'm really, really looking forward for really smart people to come with some really good solution. This is a huge problem. If you're doing testing for your microservices application, you know that your regression testing is growing exponentially with any change that you're doing to any of your services, right? Who actually experienced that phenomena here in the crowd? Well, I did. Okay, one over there. You need some scale to see it. It doesn't scale, it doesn't work, guys, okay? We need different solutions. Decentralization is a key if we want to grow, okay? And having smart decentralization, okay, is something that I think there is a lot to do, and I love the area of bio-inspired. I think it's just really mind-blowing. And lastly is monitoring, okay? So when you talk to people about monitoring and about control, usually they try to control things at a very, very granular level. Most of the DevOps guys, if I ask them here, what does it mean control? They'll tell me, I want to know everything that is happening in my system, right? I don't want anything to go by without me knowing it and controlling it. Well, guys, it doesn't mean anything in complex adaptive systems. But there is one feature of complex adaptive system that I didn't mention here, is that although they look very chaotic and unpredictable, at the end of the day, there are some things that are predictable. For example, I can tell you that Brian will probably get home eventually. I can also tell you that it will probably take him somewhere between an hour to an hour and a half, okay? I can tell you that in Ayalon Road, there are usually traffic jams on Thursday afternoon. So there's some correlation, and those systems actually have some kind of a predictable behavior. And this is something that scientists and researchers are now starting to look more and more into. But one of the most kind of, for me, amazing development is that people are trying to explore those complex adaptive networks, by the way, not just in computer sciences. Think about it. We have complex adaptive system in economy, in sociology, and many other fields. So right now in physics and biology and chemistry and many other areas, researchers are trying to find ways to better understand and to better manage complex adaptive systems. And guess what they discovered? They discovered that deep neural networks are actually capable of understanding a lot of dimensions of complexity and make sense out of them. So now people are playing with the concept that we'll take a deep neural network and it will control our microservice application, which is really cool, but it raises a philosophical question here. taking a system that we don't control and don't fully understand and is a bit unpredictable to control another system that we don't fully understand and is unpredictable. Is that control? Maybe it is, maybe it's not. It's right now, it's kind of like the best thing that we have. So to summarize, okay, I'm not talking about, if anyone thinks I'm against microservices, you totally misread me. I think microservices are the only way to go. And if you don't believe me, just look at evolution. This is the most successful way to manage applications. But what we need to realize is that cloud native is coming, and it's coming fast. And it's going to be chaotic, and it's going to be unpredictable. And we need to accept that as a fact, okay? And we need to embrace that. And out of that realization, only then we can start thinking about solutions. And this is exactly where you are coming into the picture, okay? Because we need really bright people, okay, to come up with new solutions and new ways of solving things, which are not just copying what we did with monolithic and trying to make it bigger. It doesn't work. But really rethinking about this whole area. And I highly recommend reading, and it was supposed to be bigger, but it's, okay. And I'll ask them to publish it yesterday, but you can take pictures. There's so many stuff to read online. So if you're interested in any way, I personally find this whole area fascinating. And now just a little bit of propaganda, because I have to. So I am part of the Tel Aviv Partners. I'm very proud to be part. It's a new VC fund, together with my great partners, Eitan Beck and Shachar Zafrir. We started only 3 years ago. We basically left Magma and Pitango and decided to start our own fund. Since then, we raised already 2 funds. We are now managing $270 million from really the top LPs in the US, institutional LPs in the US. And we love seed and A rounds. And after you heard me, I'm sure you understand that we love new markets, okay, and crazy concept and people that are really, really brave. And when we started TLV, we already have track record. We're experienced VCs. And this is some of our exits. And I was actually very fortunate to be a seed investor in a company called Varonis, which is now a public company, which is worth $2 billion. I'm still on the board. I'm an independent board member. And I'm really, really looking forward to invest in my next multi-billion-dollar company, which I have a feeling will come from this room. So write down my email, and we're looking to hear from you. Thank you very much.